Welcome to this chemistry class with Anakwa Christopher GK. Of course, is your chemistry teacher, and we have been on several topics in chemistry. In this particular video, we will be looking at another dimension of gas laws. This one, we will be looking at general gas equation. Before we further this topic, if you have not subscribed to this channel, if you are watching this video in YouTube, do well to subscribe to the channel so that you will be notified whenever new video is uploaded. All right, we are going to be looking at this in an in-depth aspect. Generally, what actually is general gas equation? We have done gas laws in terms of Boyle's law and Charles law, and even pressure law. We have done that, and from the gas laws, we know that the volume of a gas depends on both the temperature and pressure, and the relationship between these three variables, the volume, the pressure, and the temperature, is what summarized up what we have as this. As the general gas law, we have this as the Boyle's law, which is volume is inversely proportional to the pressure, and we have this as Charles law, volume is directly proportional to the temperature, and the combination of the both of them will have this. We'll have this mathematically. This means Boyle's law, volume that varies directly as P and directly as T. Combining both of them, you have this. And it is this particular combination that gave us what we call general gas equation. And in that, we will have this, that general gas equation. What does it state? What does it say? He says that a fixed mass of gas under any certain conditions of P and V and T, that the value of PV, which is pressure and volume, all over T must remain constant. Now, what we are just trying to say in this general gas equation is that if a fixed volume of gas, a fixed mass of a gas, let's say gas V that has a volume of V, if it is the volume at a particular pressure P, taking a particular pressure P and absolute temperature T as a T1, then the V2, which is the volume of the V2 and the P2, then absolute temperature of T2, that it will follow this particular formula. What we are just trying to say is that the V varies inversely as P, and V also varies inversely as T, which is that Boyle's law and Charles law. Combining them together, you have this as the formula, meaning that a mathematical constant of a fixed mass of a gas. The constant of it will tell us that V is inversely as P is inversely as V, and V is inversely as P. And when you open the bracket, of course, you are going to have a formula like this. P1 V1 is that of the Boyle's law, but P V all over T is that of the Charles law. So combining it, you will have this, and that is a combination for first volume and the final volume, initial volume and final volume. You have combination of this as a general gas equation. So general gas equation can be used to find the volume of a gas when both its pressure and temperature change. When temperature changes, when volume changes, we can use, or pressure changes, we can use the general gas equation to find it. So this is the combination of the three variables that affects the volume. It has to do with the nature of gas, volume, pressure, and temperature. So in the combined equation, we can find any of them. If you want to look for the volume of any of them, the value of any of them, either V1, P1, T1, V2, V2, and any of them in this particular place, you can get it there. P1, you look for P1 here, you look for P2 here, you look for T1 here, you look for T2 here, you look for V1 here, you look for V2. So with the variable, any of them can be looked for. So whenever a question is being given to you that requires three of them, you can use this relation to look for any of the variable that you are looking for. All right, let's understand this. of standard temperature and pressure, you used to have hear about STP. Now the volume of a gas, of gases, are sometimes given in standard temperature and pressure, which is STP, and the value are standard, the values, these values are, the standard temperature is this, which is 273 Kelvin, Kelvin temperature, that is absolute temperature, is equivalent to 0 degree Celsius. Now, standard pressure is 760 millimeter mercury if it's been given in mercury, and the SI unit of standard pressure when used in Newton meter, we can have this. So it depends on the particular unit that is being given to you. Newton meter, you use this one. Millimeter mercury, you use this one. Kelvin temperature, we have this. So STP, standard temperature and pressure. We just need to know it, because sometimes the value will be given, you will be told that at STP, whether provided or not provided, as long as you have been told that as STP. So the standard temperature, you just pick it. Standard pressure, you just pick it and use it for your calculation. All right, let's take some examples. One, at STP, just know now it's already been said as STP. A certain mass of a gas occupies a volume of 790 millimeter mercury. Find the temperature at which the gas occupies this particular volume, and it has a pressure of this. So volume is given, volume is given, another volume is given V2. Pressure is being given here. Another one is in standard pressure. Then you are asked to look for the temperature. All right, bringing this particular equation, we are going to have P1V2, P1V1 over T2 equal to this. When given that, you bring out this. That is the standard temperature. Is being given. You are being told that at standard temperature and pressure as STP. So P1 will now be this. T1 will be this, which is the standard temperature. Then you are looking for P2. You are looking for T2. I mean, then P2 is being given to you. There is given in the equation. Then V1, V2. Then you are looking for the new temperature. And with that, you look for T2. You make T2 the subject of formula, and you substitute directly from the question given to you, from the available data given. You substitute, and when you do so, you are going to have this as the T2. What it means that the new temperature of the gas is 330.1 Kelvin, temperature in Kelvin. All right, number two, a given mass of gas occupies this 850 millimeter mercury, cm cube at 320 Kelvin, that is temperature, and 0.92 times 10 raised to the power of 3 Newton meter square, that is of pressure, Calculate the volume V2 now. We are asked to calculate the V2 of a gas as standard temperature and pressure. That means V2 is given from standard pressure. T2 is also there. With that, you just look for V2 from the question given. All right, we can have this. The general equation once again. When we have the general equation, you bring the given data given to you. And the given data, we have this as P1 given in the equation. V1 is also given. T1 is given. P2 now, you can use this. P2 being that is being given in Newton meter square. P standard pressure now is the value of this. It's also when I was giving standard temperature and pressure, STP, standard pressure in Newton meter is being given as 1.01 times 10 raised to the power of 3 Newton meter square. Then T2 is 273 Kelvin, which is standard pressure. Then V2 is what you are looking for. And with that, you just substitute. And when you look for V2, you substitute rightly, and you will have this as your final answer. And if that is the case, that is how to solve general gas equation. The question is not how to solve general gas equation. It's not difficult, and that is what we have done so far with these few examples. Then for further discussion and inquiry, you can get to me through my WhatsApp contact. You can see on the screen, and or in my email address. That is it. Now, general gas equation, we have said, is just the combination of Boyle's law and Charles' law. And with that, you combine the formulas together and you have what you want. Thank you for being part of this particular class. And remember, blessed. Now, be ready to listen to the next video. Make sure you watch the next video on gas laws also. That has to do with Avogadro's law and Gay-Lussac law together. Thank you.